Today we're going to learn about parent functions. Now a parent function means that all functions come from this basic or parent function. Here's an example. This is x squared. Notice it has 5 points. What is a parent function? Well, if we want to be technical, it forms the basis of all subsequent functions. It contains at most one operation. Now, I want you to underline this part right here. Alright, it's not going to have like a plus and then a minus and then a divided. It'll contain at most one operation. You'll see what that looks like as we see the parent functions. Now, we're talking about this because we're going to be talking about function transformations. Function transformation is a modified form of the parent function, and it contains more than one operation. So if you see like a plus and then a minus and then a divide, or just a plus and a divide, you know it's going to be a function transformation. Now we are going to use f of x to denote transformed functions, and in this class I'm going to use p of x to denote a normal function, p of x to denote a parent function. Pretty simple, right? Because p means p for parent. Alright, our first parent function, p of x, is going to be just p of x equals x, okay? It's the same equation you looked at in algebra, y equals x, okay? Everybody knows from algebra that that is a straight line and it's diagonal at a 45-degree angle. We'll look at the graph in a second. Now I want you to focus on these x values. These are going to be some common x values that we use when graphing parent functions. We're going to start at -2, then go -1, 0, 1, and 2. That's because it's right around the center and it's easy to have a point of reference. Now notice if I plug in -2 into my y equals x function, or my p of x equals x function, I'm going to get -2 back. In other words, the y value will always be the x value, and that goes for every single number here for p of x, and it's a very simple basic function. It's a one-to-one function. When we graph our parent functions, we're just going to plot those 5 points. First point being -2, -2, and so on and so forth. So -1, -1, 0, 0, 1, 1, 2, 2. Once you plot the points, then you just connect them. And again, this is just a straight line, y equals x. Doesn't get more basic than that, and that's our first parent function. P of x is equal to x, our parent function. Next up, we have absolute value. This is going to be p of x is equal to the absolute value of x, these absolute value bars. Now, absolute value of -2 is 2, absolute value of -1 is 1, absolute value of 0, so on and so forth. Again, notice we're using the same x values, -2, -1, 0, 1, 2. You guys have seen most of these before anyways. This is going to form a V shape. Again, I just plotted those 5 points from this chart, and if I connect them, it makes a V. So the absolute value function has a V function. Next up is called the quadratic function. It's p of x, parent function, is equal to x squared. Again, same 5 x values. -2 squared is 4, -1 is squared is 1, and so on and so forth. We're going to plot those 5 points on the graph. Now this almost looks like you connect it with a V, right? But it curves a little bit, so we're going to connect it with a curve. Does anybody remember the name of that curve? If you said parabola, you're correct. You can say U-shape if you want, but technical term is parabola. Again, this is another parent function. This is our third parent function. So far we have the linear, because it's a straight line. Then we have absolute value, looks like a V-shape. And then we have the quadratic, which has a shape of a parabola. And I will be quizzing you on the shapes of these. Okay, next up we have the square root function. Square root function, p of x equals the square root of x. Now, this is one that doesn't use -2, -1, 0, 1, 2 because we don't get even square roots back for those. So these are the four, just 4 for this one. I just want you to use these 4. You could plot a fifth one. The square root of 16 is 4, but I usually just put it on a 10 by 10 grid. This would not, you can't plug in 16 on that grid, so we'll just use the first 4. But anyway, these are perfect squares, so we can take the square root of them. Square root of 0 is 0, so on and so forth, down to square root of 9, which is equal to 3. Okay, when we plot these 4 points, it looks like this, and we connect them with another curve. This is a square root curve. It's like a curvy arrow is the best way I know how to explain that, right? And that's it for that parent function, the square root of x. Now remember, these are called parent functions because they lead to, or they are the origins of, they produce other functions, like a transformed function. You could say the square root of x minus 4. But anyway, so they're all derived from these parent functions. Next we have the cubic function, p of x equals x cubed. when you cube negative 2, it remains negative. It's negative 8. Cube negative 1, you get negative 1. So we're back to our original 5x values. Those will be right around the center of the origin. And then finally we have 2 cubed, which is 8. We're going to plot these 5 points and see what the shape looks like. Alright, so I plotted those 5, and if we connect them with a curve of best fit, it's going to be an S-curve. Okay, so the cubic function has an S-shaped curve. Moving along, next we have the rational function. P of x is equal to 1 over x. Now this one is called rational because the variable is in the denominator. Alright, so we got negative 2, negative 1, 0, 1, and 2. Again, same x values. Now 1 over negative 2 is obviously negative 1/2. 1 over negative 1 is negative 1, and so on and so forth. 1 over 0 is undefined. 1 over 1 and then 1 over 2 equals 1/2. Now I do believe we've already graphed rational functions in this class, but anyways, I want you to see what the parent function looks like. Now here we're going to have an asymptote, right, because it's 1 over 0. We've learned that before. The other points, just make them decimals so we can put them on the graph. So now we have 4 points and an asymptote. First point, negative 2, negative 0.5, and so on and so forth. Okay, when we plot those 4 points and the asymptote, it looks like this. We've seen this before. It curves in the third quadrant around these asymptotes, and then in the first quadrant it curves around these asymptotes, connects these 2 points. Again, these points come from my chart. Now, there is a horizontal asymptote at y equals 0. We learned that back in rational functions, and that's because the power on the bottom is bigger than the power on top. Okay, I'm going to stop here. There's going to be a first set of parent functions. If you have any other questions about this, let me know.